Hello and welcome back. In this video, we will discuss finding the least squares regression line manually. If you did not watch my video on linear regression, I highly recommend you do so. In that video, I discussed the least squares regression line and pretty much what it means. And I don't really cover how you find that line. So this video, we're going to discuss like how do we find the equation for that line, okay? At least manually. So some definitions: least squares regression line, the line that minimizes the sum of the squared residuals. The slope m, so our line will be in slope intercept form, which is y equals mx plus b. So our slope m represents the rate of the predicted response, or the rate of change of the predicted response. And our rate is typically denoted as rise over run, or so I write triangle y, triangle over triangle x. That means you could read that as delta y over delta x, which is change in y over change of x, which tells us the angle of like, does our line have a steep angle or a not so steep angle? That's what our slope tells us. The y-intercept in our slope-intercept form, the equation is written as y equals mx plus b. Our y-intercept is denoted with the b here. And this is the predicted value when x equals 0. Our y-intercept is also useful when we have to graph this thing manually. Residuals, the observed value minus the residual value. I go over this in the previous video on linear regression. This is found with y minus y hat. And the regression equation, again, slope-intercept form, y hat equals mx plus b. And the hat just denotes that this is a regression line. It's almost exactly the same thing as, if not the same exact thing, as just a line in slope-intercept form. All right, cool. So here we have our equation with some other just definitions here. Equation, y hat equals mx plus b. Now, I said before, slope is rise over run. We have this crazy formula to figure it out. The bulk of the video is going to be breaking just this part here down. Once we break it down and understand what we're looking at, it's not complicated. This is not something that I don't think anybody expects the students to memorize. If anything, the equation will be given to you as reference, but it is expected to know how to use this thing. Likewise for B, for our y-intercept, again, I wouldn't expect any student to memorize this. But I would expect a student to see this and to know how to use it. So I denote here x sub I and y sub I. I want to make it crystal clear. X sub I and y sub I are not the same thing as the x and y in our equation. When we graph this thing, it's going to come in a form as y equals 2x plus 6. This x and this y stay as a variable. I put the sub i's here. You could see them all littered here, here, here. The sub i's tell the reader that we have a number of x elements and y elements that we will be looking at from given data to calculate this. They are not the same thing as this x and this y. This is, again, this x and this y are used to graph our line, whereas these x's and y's are our given data points. Okay, I want to make sure it's crystal clear. So I note here, x sub I is each x value given to us, and y sub I is each y value given to us. N is the number of observations, and capital sigma, the symbol we use for summation, which means sum of, which means we just add all of it together. All right. All right. Let's take a look at an example. So how do we do this? Here's our example data set. Hours studying x and quiz scores y. So like I said before with the x sub I and the y sub I, this just tells us these are our x values. These are all of our x sub i's. We have 6 of them. And these are all of our y sub i's. And we are given n. N is always number of elements, number of observations. There are 1, 2, 3, 4, 5, 6 pairings. So n is 6. Okay. All right. So step 1. On our table here, we're going to add 2 columns. We're going to add a column for x sub I squared and a column for x sub I times y sub I. So in this column here, I just take every element of the x sub I column and I square it. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. And 6 squared is 36. Then for my last column here, x sub I times y sub I, I just take these two columns and I multiply the values in each row. So 1 times 58 is 58, 2 times 63 is 126, 3 times 66 is 198, 4 times 72 is 288, 5 times 78 is 390, and 6 times 81 is 486. Okay, so that's our step one. Add these two columns. Step two is we compute the summation of all four of our columns now. Okay, so the first column is the summation of x sub I, which means the sum of all the values in our x sub I column, which is simply 1 plus 2 plus 3 plus 4 plus 5 plus 6, 21. The second one, summation of y sub I, is the sum of all the y values in our second column. 58 plus 63 plus 66 plus 72 plus 78 plus 81 equals 418. Third, the summation of our x sub I squared column. 1 plus 4 plus 9 plus 16 plus 25 plus 36 gives us 91. And lastly, the summation of our x sub I times y sub I column. 58 plus 126 plus 198 plus 288 plus 390 plus 486 gives us 1,546. Okay. All right. Step three, we plug all of our found values into the equation for our slope m. So I rewrote the equation here. I probably should have color coded like I did in this step, but I wanted to, I highlighted each of these a different color. This one I gave blue, orange, red, pink, and green, so we can quickly see where what goes what. So n, we plug in 6. The summation of x sub I times y sub I, that's our green value here, 1,546, plug that in there. Minus 21 is the summation of x sub I, we found that right here, it's 21, times the summation of y sub I, 418, we found that right here. And part of what might make this look scary before I continue is when we look at it here, we just see these next to each other. We should know that means we multiply them. When we have two variable terms next to each other, it means multiplication. We can't quite do that with numbers. That's why I put the parentheses. And parentheses are, in my opinion, the ultimate form of expressing multiplication. Anywho, so that's why I read it like that. So we plug these two values in right here. The denominator, n, again, is 6. The summation of x sub I squared, we found that right here, 91 goes there. These two get multiplied, minus, and then we have summation of x sub I squared, 21 squared. So now another thing, I mentioned this in another video worth commenting on here. The square on the inside of the parentheses versus the square on the outside of the parentheses mean two different things. This is the summation of x sub I squared, and this is the summation of x sub I. Whatever that value is now squared, okay? So that's why we put the square on the outside. So that's why these two 21s are the same, because summation of x sub I is 21, summation of x sub I is 21, and now we're squaring that, where this is we take x sub I, square it, add all those up, and that's our purple value of 91, okay? So from here, we just, perform our orders of operations and just solve this thing. These two numbers multiply to 9,276 minus these two values multiply to 8,778. These two values multiply to 546 minus 21 squared is 441. Numerator, these two values subtract to equal 498. Denominator, these two values subtract to equal 105. Plug this into a calculator, rounding to 2 decimal places should be fine. We found our slope approximately 4.74. All right. Step 4, now we calculate the y-intercepts, our b. So again, just use the same given data from the table. The only addition is we now found m in this last step, which I highlight in yellow, so I tried to note in yellow. I know the yellow and the orange look really similar. But summation of y sub I, we found that to be 418 minus m. The product of 4.74 times 21 gives us 99.54 divided by 6. Subtract the numerator. 418 minus 99.54 equals 318.46. Divide that by 6. Bam, we found B. Again, it's okay to round to 2 decimal places. I got approximately 53.07. It was probably 53.06 repeated, but we don't need to write an infinite number of 6s out. So cool, that's it. And we found our line. Now we plug in step 5 and the final step. Substitute values for m and b into equation for least squares regression line. M is 4.75, b is 53.07. The least squares regression line for the given data is y hat equals 4.75x plus 53.07. Like I said, it's a couple of steps, but each individual step is not difficult. So how can we interpret this? The slope each additional hour studied is associated with an increase of about 4.75 quiz points. And the intercept tells us a student studying 0 hours is predicted to score a score about 53.07 points. Oh. Some common mistakes. Forgetting to calculate the x squared or x times y. I should have the sub i's here, not the most important thing, but let's put those in. You get the idea. Forgetting to calculate the x sub I squared or x sub I, y sub I correctly. I'll write this neater before I upload it. Mixing up slope and intercept formulas. You can't do the intercept formula until you find slope. So you should know if it has m in the equation, it has to be the intercept one. Using y instead of y hat for a regression equation. That's just good habits to build because it tells your reader what exactly you're looking at. And one of my favorite things about mathematicians is they are actually amazingly lazy people. But it's a productive laziness where instead of writing out all these long words, they just assign little symbols so they don't have to write out the same words over and over and over again. But that being said, if you in class you write, you don't put the hat on the y. Depending on your teacher or professor, they're not going to give you too hard of a time about that. That's not the most important thing, but it's good habit to do it the right way. And lastly, rounding too early during calculations. I told you I don't round anything until I get the final step. If in my work I get a fraction, like I can't think of a good example here, but like say this number was some like 21 over 47, which equals, yeah, there we go. This equals 0.4468085, blah, 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 blah. This equals a long string of numbers. I would keep this in this form until I get to the very last step, and then I would round. If you round too early, it might make errors in later steps. And in a previous video, I mentioned how fractions reign supreme. That's one example of many of why fractions are superior to decimals. The more accurate results lead to less error in the future. Okay. All right. And then we have a practice problem. Let's get this all on here. Can we see? Yep. Okay. So we have this given data here. Okay. And steps 1 through 5 pretty much build to finding the least squares regression line. Add the two columns, x sub I squared and x sub I times y sub I. Compute the summation of each column, find the slope, find the intercept, and write out the equation. I encourage you to pause here and take a stab at this. Cool. All right. Let's take a look at the work. So, step 1, got to make the tables. X sub I squared is all of these terms squared. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36. Second column, x sub I times y sub I. Find the product of these 6 rows right here. 1 times 61 is 61, 2 times 67 is 134, 3 times 69 is 207, 4 times 76 is 304, 5 times 80 is 400, and 6 times 84 is 504. Cool. All right, step 2, find the summation of each column. The summation of x sub I column, 1 plus 2 plus 3 plus 4 plus 5 plus 6 gives us 21. Summation of y sub I column, 61 plus 67 plus 69 plus 76 plus 80 plus 84 gives us 437. Summation of the x sub I squared column, 1 plus 4 plus 9 plus 16 plus 25 plus 36 is 91. And lastly, the summation of the x sub I times y sub I column is 61 plus 134 plus 207 plus 304 plus 400 plus 504 gives us 1,610. All right. Step 3, find our slope. Okay. So there's 6 elements, n equals 6. We found that summation of x sub I times y sub I equals 1,610 minus summation of x sub I 21 times summation of y sub I 437. All this divided by, again, n equals 6. Summation of x sub I squared is 91 minus the summation of x sub I, that value squared, x sub I is 21, and we square that. Again, be mindful, do not mix up these two. It's very easy to, but they represent different things because the squared's outside here, whereas the squared is inside the parentheses there. Okay. And then we just simplify, do the math out, blah, 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 blah. 483 over 105 gives us exactly 4.6. Hopefully you found your solution of slope to be 4.6. Okay, step 4. Now we find the y-intercept. We use our equation here. Summation of y sub I equals 437 minus our slope m 4.6 times summation of x sub I 21 divided by number of elements 6. Do the math. 430.4 divided by 6, b is roughly 56.73. And lastly, we plug our slope and y-intercept into the equation for slope-intercept form. Y hat equals 4.6x plus 56.73. Whew, a lot of numbers. But that's all I have for you on this video. This was more algebra based. To be honest, I much prefer algebra to statistics. I'm actually starting with stats videos because this is my least favorite of the math, and I kind of just want to get this one over with. Anywho, this is more fun for me. I'm just in it for the love of the game. But ranting aside, that's all I have for you this video. The next video, I'll show you how to do this with the TI-84 graphic calculator. Thank you for tuning in. As always, a link to the notes will be in the video description, and I will see y'all next time. Take care.